My name is Muhammad Sakir Hussain.
Myself, Mohammad Tanzeel Adam Khan.
My name is Aijaz Mustafa.
My name is Abhishek Gupta.
Together, we are working on timetable generation using CSP.
Under the supervision of Dr. Arjit Mandal sir.
So, let's get started.
So hello everyone, this is Mohammad Tanzeel Adam Khan and I welcome you to this video where we are going to talk about timetable generation using Constraint Satisfaction Problem. This project is instructed by Professor Arjit Mandal sir. So in this video, we are going to study how to generate a timetable using the given conditions, given rule, given availability and the courses of the professors. So the table of contents are introduction, problem statement, input data and format, constraints and rules, quality matrices, methodology, algorithm design, result and analysis, conclusion, references. So in this video, we will be going through all the circumstances to generate a timetable and what are the requirements we require to generate the timetable. Talking about the introduction, this project addresses the classic scheduling problem of timetable generation by automating IIT's Patna spring semester schedule. It considers student enrollments, faculty availability, classroom capacities, and course structure to create an efficient, conflict-free, and optimized timetable using algorithmic techniques. So now, what is the problem statement? In this video, we are going to take this problem statement where the goal is to automatically generate a timetable for all spring semester courses at IIT Patna, considering each student's subject, combination, and course structure, including lectures, tutorials, and practicals. Session must be scheduled between 8 a.m. to 6 p.m. with a lunch break from 1 p.m. to 2 p.m. using available classrooms and faculty. The system must address key constraints, no time clashes for students or faculty, room allocation based on capacity and type, adherence to course format like if we have a 3-credit format of a course or a subject, either we can distribute into 1 hour each day for 3 days or 1 hour class on the first day and 2-hour class on the second day, a week. Subject with up to 2 faculty members should be avoiding conflicts. Quality factors like minimizing class gaps, avoiding early late slots, and reducing room switches. The scheduler reads CSV formats like students, data, subjects, faculty, and availability of room, and produces a conflict-free, optimized timetable that satisfies all constraints. So, talking about the input data and format. So as you can see on the screen, we are having student enrollment file, which means we will be having the roll number of the student and which course, which subject they are enrolled. So in this example, we have taken 4 subjects. So the roll number 2101 CS 0101 has taken CS 301, CS 302, HS 201 and MA 202. Similarly, there are 3 students what we have taken the same example. And coming to the subject detail file. So how many lectures are required for a specific subject? So we are having 4 subjects as an example. So we will be having 3 lectures. For example, in the CS 301, we are having 3 lectures, 1 tutorial and 2 practicals. Now talking about the faculty. Which faculty will be teaching which subject and how many subjects? So for example, F001 faculty will be teaching subject 1 as CS 301 and subject 2 CS 302. Similarly for all the other faculties. Now talking about the room availability and capacity of the room. So for example, we have taken LH0101 for the capacity of 60 students. For LH02, we have taken 45 students capacity. In CS lab, we will be having 30 seats and in EC lab, we will be having 25 seats. Now I would like to introduce Abhishek for making understand about the constraints and rules and some more further explanation. Thank you.
Thank you, Tanzeel. So now I am going to tell about constraint and rules which we will be using in timetable generation. First is no classes allowed. So there should be no classes like if a faculty cannot be assigned to 2 different subjects or classes simultaneously. If a faculty is assigned to a class, then he can't be assigned to other class. Second is the class timing constraint. So the class timing constraint will be same for lectures, tutorials and practicals. Rest there will be one lunch break which will take place at 1 p.m. to 2 p.m. Third is lecture scheduling rules. So as Tanzeel also mentioned that how we are going to schedule the lecture. So there will be like if a subject is of 3 credit, then that faculty can take 1 plus 1 plus 1, that is 1 hour a day in a week. And one more is there, one more like we can schedule 2 plus 1, like 2 on one day and 1 on another. So lectures should be spread across the week and not placed in early morning or late evenings unless necessary. Fourth is the practical scheduling rules. So there should, if a practical is of 2 credit, then it should be a 2-hour continuous slot, and if it is of 3, then it should also be continuous. Fifth is tutorial session rules. So tutorials should be scheduled after the respective lecture topics, and faculty assigned must be available on the same slot. Faculty availability constraint. So faculty members have limited weekly working hours, so we have to choose it wisely. So for that we should respect the preference and unavailable time slots. Seventh is room allocation rules. Room should have sufficient capacity to accommodate all the students. So now I am going to tell about the methodology which we will be using in timetable generation. So timetable generation is basically, we can say, a classical constraint satisfaction problem. It involves assigning lecture, tutorials and practicals to time slots and rooms without classes for student, faculty or resources. So various methods have been developed. So these methods are, first is the brute force method, which is also known as the naive method or basic approach. Greedy algorithm, which is also known as heuristic method. Third is the backtracking algorithm, which is also known as, like, we can also use recursively, we can train constraint satisfaction. This is the classical constraint satisfaction problem which we will be working on. So brute force method. So brute force method tries to generate all possible combinations of time slots, rooms and faculty assignments for every lecture. Then it checks all the constraints, and if a room is available or if a solution is available, then it finds a guaranteed solution. If I talk about the advantages, then it is a simple and straightforward logic, and if I talk about the disadvantage, then it is extremely inefficient as it is a brute force method. Second, greedy algorithm and heuristic. The greedy approach makes locally optimal choices to build a feasible schedule. So the advantage here will be, it will be more efficient as compared to brute force, and it will be also fast and practical, but disadvantage will be like it may miss the best or even a valid solution. Third, backtracking algorithm. As I said earlier, that backtracking solution is a recursive method to assign time slots and rooms by checking for constraint satisfaction. If a conflict arises, it backtracks and tries another option. Its working principle are, it will start with an empty timetable, then it will assign one class at a time. Then if a constraint occurs, then it will backtrack. Like if we get a bounding solution, then it automatically backtracks. So its advantage will be it handles complex constraints, it provides valid class-free schedules. Disadvantage will be slow for large data sets. Constraint satisfaction problem. Constraint satisfaction approach treats timetable generation as a CSP with defining variables, domains, constraints. What are variables? Variables like courses, rooms, time slots, faculty. Domains, possible domains will be possible values for each variable. Constraint, there should be no classes. There should be like minimum amount of room capacity, availability of room capacity and labs. Technique used will be forward checking, like it prunes domain values that lead to future conflicts. Like if a conflict arises, then from before only it will prune that possible solution. Constraint propagation narrows domain of related variables after assignments. Advantage will be it will handle complex dynamic scheduling, and it will be efficient than all the solution. So now I would like to call Sakir to further explain the algorithm which will be used. Thank you.
Thank you, Abhishek, to giving me chance to continue presentation on timetable generation, and Abhishek explaining the methodologies, and now I am going to explain the algorithm design for timetable generation. The first step to timetable generation, that is variable and domain. Define the variable and domain, and it also called the timetable component. In like that, the various there is lots of variable in timetable generation, that is courses, faculty, student, room, and time slot. And the courses is the subject to be scheduled. Faculty, the teacher are assigned to the courses. Student that are enrolled for the courses. And room with the availability with the capacity. And the time slot for the courses, 1 hour, 2 hour for a particular subject. And these are the variable, and the domain are the valid options like available room or time slot. The second step is define constraint. Constraint is very important for any type of project, or work. There is the two type of constraint: the hard constraint and the soft constraint. Hard constraint is must be followed in any situations. It must be followed. But the soft constraint, it may be flexible, prefer to be flexible. If it not satisfied, then it's okay, no problem. But the hard constraint, it must be followed. The hard constraint are in the timetable generation, there is the no faculty or student can have overlapping classes. And the second hard constraint is room can't be double booked. And the main and the very important constraint, that is the practical must be scheduled in the lab. Consider, and in the soft constraint, there is the consider faculty availability and preference, and limited classes per day for the student or teacher. Maybe someday, if required, the teacher and faculty can take more classes, extra classes like on Sunday, Saturday, on weekend classes. That is the soft constraint. The third step is sort subject. It is sorting subject for the efficiency. To reduce conflict, subjects are sorted before scheduling. Less flexible subject and lab and long classes are scheduled before the regular lecture. Large or core subject get room priority. The priority sorting help streamline the scheduling process. The step 4, it defines the slot assignment using backtracking, greedy, and CSP. We use the CSP. In the CSP, there is the two step. First is forward checking, and the second is constant propagation. And we also apply heuristic with MBR and LCB. In the step 5th, conflict detection and resolution. Conflict detection and resolution is despite careful design, conflict can occur. The algorithm handle them using a conflict checker that is detect double booking, student, faculty, or room. Like that, no a particular student go in the two classes at the same time. Like same as faculty not assign for the two courses at the same time. That is the conflict. And also a particular room can't assign for two or more courses at the same time. We have to remove this type of conflict and minimize penalties for soft constraint violation using a scoring in advance method. And the last step, that is the output generation. After going all last 5 steps, we are come to output generation. That is, once the timetable is complete and validated, display it in readable tabular format showing time versus day slot, subject, faculty, room per day per slot, and digital file, CSV, PDF, HTML, print friendly format for student and faculty. Now I am going to explain how the code is working. Okay, let's see how the code is working properly. For timetable generation, we use 3 type of approach. The first is CSP based, that work on constant and variable, and the second is meta heuristic, and third is heuristic, that is priority greedy based. For this, we are included the 4 type of CSV file format, data format. That first is subject. In the subject there is in subject we have the subject with code, subject code ID I mean, and that in each subject have the number of lecture, tutorial and practical. And second is a student with roll number, and a student enrolled in which subject, and in which subject, that are subject with subject ID. In the room number with room number and the capacity. In the faculty, the data format is faculty ID with the subject ID that are allotted to a particular faculty. Now come on our code for CSP based approach. First we load these all four CSP file format, and then we define the time slot and main timetable generation function, that in that we define the constant variable and the lecture slot with working, and we define the time slot in two zones. First is before the lunch and after the lunch, and we define the constant, the lab, the practical session I mean the lab, it must be consecutive for the 3 lecture continuously. And we also define the soft constant, like we have to assign the class as late as possible early in the morning, and before and very early, and make very early in the evening. Now run this code, and it take at least 30 seconds. Now it's working properly, and we seen here the timetable, our timetable generated in the Excel file, that as the name as output underscore CSP based format. And now look see how our timetable is generated, and this is look like this. Okay, now come on the second approach, that is meta heuristic. In the same we included the first time we included the file format, second load all the files data format, and the second and the time slot we included, and it here we in meta heuristic we define in meta heuristic the algorithm work as genetic algorithm. In that there is the there is some important part, that is the chromosome is one complete timetable. Like in our project there is the subject, date, time, its work as chromosome. And the second important variable for the genetic algorithm, that is in single subject index with the day, time, room pair. And the fitness measure how many conflict violation a schedule has, and the population a group of different timetable. Mutation, and the next is mutation, randomly change a slot in the timetable. And the last is selection, and now after generation all the timetable we have to choose the select the best schedule for the next generation, like as our timetable meta heuristic work. Now run it. After all generation and fitness work properly, it generated our time table in Excel file. Now see how it's look like. Okay, the meta heuristic timetable generated like this. Okay, this is timetable generated by the meta heuristic algorithm. Now we know there is some limitation of meta heuristic. The first is it does not enforce lab grouping or back-to-back lab slot. And the second limitation for meta heuristic, that is no guarantee to coverage to converge to a perfect solution, and slight randomness different output to each. Now let's come to our third and the best approach, that is priority based greedy approach, that give the best and optimize or timetable. Okay, in this all this code is same as like CSP based. First we load the all file format, and then we define the time slot. After that we build the mapping with the roll number and subject, and define all the constant, and after run the heuristic approach, that is the priority based greedy. Okay, now let's run it. it's working. It worked very properly. Okay, and it generated timetable in our Excel file. Now let's see how it's look like. Okay, this timetable generated by the heuristic approach that used the greedy priority based greedy approach. And this timetable is very optimized to a comparison to meta heuristic and the CSP based format. CSP based that CSP work on the constant and variable. Now you understand the code working in these steps, and after the code the result is generated like a tabular format. In the tabular format there is a simple timetable view to understand you, that is in the first column there is the time, like first hour time slot, second time slot, third time slot, like that 8 p.m. 8 a.m., 9 a.m., 10 a.m. and so further, and the lunch time is 1 p.m. to 2 p.m. and the working day Monday, Tuesday, Wednesday, Thursday, Friday, and each time slot have with the corresponding days there is a course assigned and with the faculty name. That is the simple timetable view. That is the simple timetable view. And thank you. And now I would like to call Aijaz Mustafa to continue and explain comparative study of approach and conclusion. Thank you.
Thank you, Shakir. Now, I would like to explain comparative study of approaches. If multiple algorithms were studied or implemented, their outcome can be compared based on their performance and scalability, right? So, we will consider about the methods, like what are the methods here, as Shakir and Abhishek already told: greedy algorithm, backtracking, and CSP based algorithm. And the factors that we are considering over here is execution time, conflict free, whether it's a conflict free or not, quality of a schedule, and what is the scalability of that. So first of all, I would like to go for greedy algorithm. Its execution time is very fast. Okay, and it's a conflict free. Quality of schedule is medium, like it's comparatively to backtrack and CSP, it's medium. Scalability, if we talk about the scalability, it's suitable for the small and the mid-sized data sets. Like the data sets you are using, if they are small and if they are comparatively in between, then the data set is not too high, then the greedy algorithm would be the better option you to choose. The second one is backtracking. The execution time over here is moderate, like it's not too fast, it's not too slow also. It's a moderate. It is also a conflict free. And if you talk about the quality of a schedule, it's very, very high. And scalability, slower with the large inputs. Like if you are using some large data sets, then it will give you output, but the output will be a slower way. It will be a slow. CSP based algorithm. Now the last one method is CSP based algorithm. It is slow. All the methods are conflict free. So it is also a conflict free. But the quality of a schedule is very, very high. Okay, and scalability, if I talk about the scalability, high scalable and more, and it is very, very much flexible. So that was a comparative study of approaches. The second slides which says is the conclusion. Oh, so we are at the end of the slides. So the conclusion part, project summary. What we have done over here, we have developed an automated timetable generation system that process student, faculty, course and room data to create an optimized and conflict-free schedule. Like we are creating a schedule that has to be a conflict-free. There should be no conflict between the classes or between the professors. So we are creating this over here using constraint satisfaction and heuristic technique. The system effectively handles what it handles: the hard constraints like what I already told, class clashes, room capacity and practical continuity. Quality factors such as minimal student gap, reduce room switching and balancing faculty workload. And what are the current limitation on this? Assume like clean, complete input data. There is no user interface, and there is a lack of real-time adaptability. Soft constraints, time preferences not considered in optimized manner. What are the future enhancement like we are planning to do? Develop a graphical user interface for this and enable a dynamic reschedule and preference handling using AI. Dynamic rescheduling means like there will be some changes in the timetable. There will be some professors who will teach or who will not teach. So doing that dynamically will be our preference, and that we'll do in the future. Improve scalability and add calendar export functionality for the broader adaptation. I hope you got this. Thank you so much. Thank you guys. I hope you like this. If you have any sort of query,
You can reach us at our mail given in the description box below.
Thank you for watching.
And hope you like this video and subscribe to our channel. Bye.